If you are using GitLab CI, probably you are pushing your code at a fast pace, but are you catching vulnerabilities before they hit production? In this video, I'll show you how to set up an automated dependency scanning in GitLab CI, and more importantly, how to stop deploying to production if the GitLab CI pipelines catch vulnerabilities in your dependencies. Let's dive in and get started. Dependency scanning checks the external libraries and packages your code depends on for known vulnerabilities, including nested dependencies. By running the dependency scanning in the development, you can detect vulnerabilities earlier in the pipeline and address them before they reach production. And once the scanning is completed, GitLab shows the vulnerabilities in the merge request and also saves the reports in the form of JSON into the pipeline artifact. Let's jump into the GitLab dashboard and start building our secure pipeline using GitLab CI. On the GitLab side, to utilize the dependency scanning, you need to make sure that you have an ultimate license for the GitLab. You can use that ultimate license in the gitlab.com, your self-managed GitLab, also with your dedicated GitLab instance. Once you have your GitLab ultimate tier, you can go to the gitlab.com and click on create new repository, create blank project. I'll call this project dep-scanning. Now my project is ready. For this demo purpose, I'll be trying to scan a Python project where the packages will be mentioned in the requirements.txt file. So I'll click on new file and this will redirect me to the internal IDE. Here I'll click on new file. I'll call this file requirements.txt. Inside this requirements.txt, I'll add this Python package request with the version 2.19, where this version has some known vulnerabilities, so we can confirm and test this package if the dependency scanning finds out any vulnerabilities or not. I'll commit these changes. So now my requirements.txt file is ready, and next I'll go to the build and pipeline editor. I'll click on configure pipeline. I'll select all these existing stuff and I'll include the dependency scanning by adding this template here called jobs/dependency-scanning.gitlab-ci.yaml. So this is a predefined template from the GitLab which actually adds a dependency scanner to your CI pipeline. So now I'll go and commit these changes. I'll go to the pipelines. And here you can see that the pipeline has included a new stage called test. If I go to the details of this pipeline, you can see that the scanning is running here for the Python, and if I go to the details of this dependency scanning job, and here the scanner has automatically detected that this is a Python project since it has a requirements.txt file, and based on the project it has started downloading this scanner called Gymnasium Python version 5. After that it is pulling the repository and then it has started running the analyzer run command here, and the analyzer run command will go through the requirements.txt file if it found any, and if there is no requirements.txt file in the root directory, it will go deep into each directory within the project and it will start looking for the requirements.txt file inside the nested directories as well. So here it has found some vulnerabilities, and the vulnerabilities are saved into gl dependency scanning report.json. If you want to see the details of this scanning report, I'll go back to the editor. And here I'll override the scanning job by adding a new script here called after script, and inside the after script I'll do cat gl dependency scanning report.json. This will actually list down all the contents from this gl dependency scanning report.json, so we can go through all the details and then we can see how many vulnerabilities this scanner has detected. Commit these changes. I'll go back to the pipeline. The job has succeeded and you can see the contents of the scanning report.json file. So here it has vulnerabilities with severity medium, and you can see all the list of vulnerabilities including the details of which package or which nested dependencies has what vulnerability inside that package. And here you can see the scanner has suggested some solution as well to upgrade to version 1.2.6 for the URL lib3, and this way you can go through all the details of these vulnerabilities vulnerabilities, and if you want to fix any nested package, you can check for the recommended solution. But what we are interested in is that if the scanner finds any high severity vulnerabilities, we do not want to push our changes to production. So we need some way to detect whether the scanner has identified any high severity vulnerabilities, and in that case we will stop our pipeline and the changes will not actually go to the production. So GitLab-ci does not provide this way by default. GitLab only does the scanning, and then it will give you this file for all the vulnerabilities report. And if you want to have some customized solution based on this vulnerability report, you can parse this JSON file, and then you can customize the scanning job script to exit the pipeline if you found any medium or any high severity vulnerabilities. So for that, I'll go back to the pipeline editor. And first I'll add a dummy build stage here. So the stage is build, and this will use Alpine image, and I'm just printing the echo build project to see that the build is happening before the scanning. And next I'll add another stage called deploy. This is also a dummy deploy stage. We just want to see that first the build stage will happen, and then it will do the dependency scanning, and if the dependency scanning finds any vulnerabilities, the deploy stage should not happen. And if the scanning gets successful and there are no vulnerabilities, the deploy stage will happen and the changes will go to the production. To override our dependency scanner, I'll remove this after script and I'll add this allow failure false. So this is by default true, and even if the dependency scanning job fails, the pipeline still does not exist and it goes to the next stage. In this case, since we don't want to run the deploy stage in case the dependency scanner finds any vulnerabilities, so we want to set this flag to false. So allow failure will not be allowed. If the dependency scanning stage fails, the deploy stage will not happen. To exit the pipeline in case the dependency scanner finds any vulnerabilities, I'll override the script part of this job. So here I'm first running the analyzer run command, which is the only command executed by this dependency scanning. Next, I'm counting the high severity vulnerabilities inside this gl dependency scanning report.json, which we just saw that it has a list of vulnerabilities with the severity medium, low and high. In case we found any high severity vulnerabilities, from the vulnerability key and then severity is set to high, and then here we are getting the length. If the count is greater than 0 here, then we are exiting the script. If the count is 0, this means that the scanner didn't find any vulnerabilities and we are good with the scanning part. If this script exit here, this means that the dependency scanning job failed here. Since we have set this allow failure to false, this will actually mark the pipeline as failed as well, and the deploy stage will not happen. You can notice here that we are using this JQ library. So JQ library is a sort of jQuery for the JSON file parsing. So this JQ library is not available by default inside this dependency scanning job. To install the JQ library, I'll add this before script, and then I'll do apt-get update and I'll install the JQ library here by using the apt-get install command. Now if I commit these changes, first the build stage should happen. Next it will do the dependency scanning, and if the dependency scanning passes, then it will do the deploy. Otherwise it will skip the deployment stage in case the scanning has failed. Now I'll go to the pipeline and I'll go to the details of the pipeline, and here you can see we have 3 different stages. One is the build, then we have the test where the scanning will be happening. At the end we will have the deploy, which will be dependent on the scanning job. So the scanning job has failed as it was expected, because that request package for the Python has some known vulnerabilities for that specific version. Since the scanning has failed, the deploy stage is skipped. Now I'll go back to the repository. I'll go to the requirements.txt. I'll edit this file here, and instead of this specific version, I'll leave it on the Python pip manager to install the latest version of the request package, which may not have some known vulnerabilities. Now let's commit these changes. Go back to the pipeline, and this time the dependency scanning has successfully completed, because that latest version of the request package does not have any vulnerabilities. Maybe there could be a low vulnerabilities, since we are just checking for the high vulnerabilities and the scanner didn't find any high severity vulnerability, so the scanner actually get passed and the deploy stage happened. So this was a quick video on the dependency scanning, which could be beneficial in case someone is more concerned about the security issues before they hit the production. This was for the Python, and it was based on the requirements.txt. But if you are using other Python package managers, or if you are using npm or yarn or Ruby on Rails gem, you just need to include this template from the GitLab, and then you can customize that job based on your language, either Ruby on Rails, Java, Node, and then you can customize the script here based on how you want to handle the vulnerabilities.